All right, guys, today we're going to be starting into chapter 6, talking about polygons, different types of polygons. As a matter of fact, the biggest extent of our chapter is going to be on quadrilaterals. But the beginning of this chapter really starts talking about polygons in general and talks about the angle sum theorem, which again sounds really complicated, but really it's not. And so our mission, we do have a big mission today, is I can identify polygons by their number of sides and find the sum of their interior and exterior angles of a polygon. First, let's talk about what a polygon really is. Again, let's just talk about the word polygon, okay? And so we see, again, this prefix poly, which if you've been in Algebra 1 or about to be in Algebra 2, you're going to see this again. This is not going to be the first time you're going to see it. So poly here really means many, okay? And so when we're talking about a polygon, we're actually talking about a shape that has more than three sides. Again, because a three-sided shape, we call that a triangle. But anything above three, we actually can get a various number of different types of shapes. And it goes right on up and up as far as you can possibly think or imagine, okay? So when we're talking about polygons, we're talking about any shape that is greater than three sides, okay? And there's a lot of different names for these that we could actually look at. And they're all named based on or identified based on their number of sides. And so I want to pull up something here real quick and just let you kind of see, because I think a picture is indeed worth 1,000 words. So instead of me sitting here talking, let me just show you some different geometric shapes. Okay, these are different polygons. And you can see here that we're starting with the triangle. Again, has three sides. But then when we move to four sides, and this is a little bit incorrect or deceiving, I guess I should say, they list out a square, but there's actually a ton of different quadrilaterals, which is really going to be the subject of this entire chapter. There's a rectangle, there's a rhombus, there's a kite, there's a parallelogram, there's a trapezoid, there's all kinds of different shapes that we can actually talk about here. But again, just basically with four sides, that'd be better to say it's a quadrilateral. Here you see five sides is a pentagon. A hexagon is six sides, which again, these are ones that we've kind of seen or heard of before. The Pentagon, obviously, is a building that's in Washington, D.C. that has five sides. Hexagon is, again, something that we've seen before. Maybe this one we've not seen. 7 is a heptagon. 8 is an octagon, which there's a very familiar thing that we see if we're out driving a lot, okay, which is a stop sign. A stop sign is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 11 is a hendecagon. And 12 is a dodecagon. Okay, so there's those get a little bit more complicated. Once you get up above 12, they just say it's a polygon with 13 sides or a polygon with 14 sides. What I want you to notice is we started with a triangle, and notice kind of the progression here. Notice what this is getting eerily close to. All right, it's getting closer and closer to the shape of a circle, okay? A circle, I want to go ahead and tell you right now, is not a polygon because it does not have sides, okay? Polygon means many sides. And so a circle is not a polygon, but you can kind of get the idea of what's going on here. These prefixes, penta is 5, oct is 8, deca is 10. So you can kind of see what they're talking about. And these are important. And I want you to reference these because on some of these problems that you're going to be given, you're going to be asked to identify the polygon just based on the name, okay? So those are the different polygons that we're kind of talking about. But what we want to talk about when we're talking about finding the sum of their interior angles, it takes a little bit of of proof, I'm going to call it. We've got to kind of take ourselves through. And so let's just look at this, and we're going to kind of see if we can see some patterns. So if I draw a triangle here, we know that this triangle has three sides, right? The triangle has three sides, and it is just one triangle, as a matter of fact. And if we were talking about the sum of all these angles, again, we don't even know what these angles are, but we do know that the angles inside of a triangle, based on the, I don't know, 3 or 4 chapters that we've already looked at, that the sum of all those angles inside is 180 degrees, right? So let's think about if we add some more sides to this. If I make this kind of like a square, Again, it's my drawing, so it's probably not going to be square. But if I make something that kind of looks like a square, you notice this square has 4 sides. But what I want you to notice is if I make a dotted line, as a matter of fact, I'm going to go ahead and change colors on this. I make a dotted line right there. I could actually represent this same square as 2 triangles. I'm going to start abbreviating because this is going to get crazy. Okay? And if it's 2 triangles and each triangle is 180 degrees, right? This is 180 degrees here. Then that means this has to be 180 degrees. And this also has to be 180 degrees. So because I have 2 triangles inside of a square, then I have to say that the sum of all those angles is 360 degrees. All right, what if I have something that has 5 sides on it? What if I've got 5 sides? So now I've got 5 sides. And if I think, again, the same pattern up here about making triangles, check it out, even though my drawing, again, is terrible, you can get the idea here that I've actually got 3 triangles here. So if I have 3 triangles, that means, again, these are 180, 180, 180. Now I've got 3 sets of 180, which actually equals 540 degrees. One more. Let's look at the hexagon. Again, the hexagon has 6 sides. So we will try our best to try to draw that one out. And again, using that same methodology, here I am attempting to make some triangles, and notice what happens there. I have 6 sides, and now I have 4 triangles, and I have 4 sets of 180. So 4 sets of 180 is going to be 720 degrees. Hopefully by now you're starting to discover a pattern. Notice this. Look at the relation between the 3 and the 1, the 4 and the 2, the 5 and the 3, 6 and the 4. And so as I go up in sides, notice what happens. My number of triangles always trails by 2, right? 3 minus 2 is 1, 4 minus 2 is 2, 5 minus 2 is 3, and 6 minus 2 is 4. So it always trails by 2. So if I could make me a formula that would use those number of sides, then it could mean that no matter how many sides my particular figure has, then I could figure out the sum that would be inside of that particular figure. So here's what we come up with. Let's say that n is our number of sides. Okay, n equals number of sides. So what did I do with n here? I need to first of all subtract 2 from it. Okay, but now how do I figure out this sum here? How do I come up with 720? Well, notice if I take the 6 minus 2, that gives me 4, and I had 4 triangles here, which all add up to 180 degrees. So if I could take this number that I have here now, whatever n is, minus 2, and multiply it times 180, and now all of a sudden I could come up with this 720 in this particular case here. So again, this particular formula here works for any kind of polygon that I'm working with if I'm trying to find the sum of the interior angles. So let's practice here real quick. What if I said find the sum of the interior angles of a decagon? Well, remember a decagon has 10 sides. Okay, so really simply all we have to do is put it into this formula right here. So I'm going to say n, which is my number of sides, n equals 10 minus 2 times 180. That gives me 8 times 180, which in fact equals 1440 degrees. 1440 degrees inside of a decagon. Okay, if I add up all those little angles that are inside of that decagon, I'm going to get 1440 degrees. Now, what if I'm trying to find an individual angle inside of here. In other words, this five-sided figure, which we declared was a pentagon, what if I was trying to find just one of those, okay? So there's a term that you need to understand, and they're going to use this term a lot, and it's going to be regular. And when you think about the word regular, you think, well, that just means common, okay? But when we're talking about this in geometry terms, when I say the word regular, I'm actually meaning, like, for example, a regular pentagon. If I'm talking about a regular pentagon, that means every single side is exactly the same. Okay, now use your imagination with mine, because mine's obviously it's me drawing. But again, what if I were to put congruency marks here? That would help you to understand that every single one of those sides are the same. Now, if you remember when we were talking about triangles, you would remember that the angle opposite of similar sides would also be the same. If these sides are all the same, then that means the angles also have to be the same, okay? So if we're talking about a regular pentagon, and I was asked, okay, what is this one angle right here? What is the angle X? All right, I don't know what it is right now, but I can figure out what the sum of all these angles are, right? It's the formula that I just had just a few minutes ago, n minus 2 times 180. So if I take a pentagon, which has 5 sides, a regular pentagon, and I put in 5 minus 2 times 180, 5 minus 2 is 3 times 180, which is going to equal 540 degrees. And magically, look here, that is exactly what we come up with just a few minutes ago right here, okay? Now the question is, okay, this whole thing is equal to 540 degrees. But what is that individual one right there? What is this angle X? Okay. Well, remember, if I have 5 sides, I also have 5 angles. Notice here, 1, 2, 3, 4, 5. And those 5 angles have to be the same. Okay. So if I'm looking for just the individual, this up here, I was looking for the sum. Okay, but if here I'm looking for the individual, like this X, then I take that same formula, the n minus 2 times 180, and I'm just going to divide it by how many sides I have, which again is n. So in this case, I figured out that the sum was already 540. All I need to do now is just divide that by 5. And if we take 540 divided by 5, we'll figure out that actually equals 108 degrees. So that means every angle inside of here, these green angles, are 108 degrees. And if I add up all those 108 degrees, then it's going to equal 540 degrees. Okay? So this is the way you need to do the first 2 types of problems. Again, this is finding the sum. This one is finding an individual interior angle. Okay? Now let's talk about something else. Let's talk about exterior sums, okay? So let's start out kind of where we started a few minutes ago, and let's say that I have a regular triangle, okay? And I'm trying to figure out what this angle right here is. Trying to figure out what this angle is on the outside. Now remember, by calling this a regular triangle, then I understand that that's actually an equilateral triangle. And remember, it has to add up to 180 degrees. So if I take 180 degrees divided by 3, which are the angles that are here, then that means each one of these angles are, in fact, 60 degrees. Okay? Each angle inside of this equilateral triangle has to be 60 degrees. Well, remember that I've got a straight line here. I've got a straight angle. And straight angles always equal up to 180 degrees. So what that tells me is that this angle X right here has to be 120 degrees. Well, what if I made another line here that comes straight off of my triangle? Then that means that this also has to be 120 degrees. And let's do it one more time. Let's say I made a straight angle off of here. Well, if this is 60 degrees and this has to add up to 180, then this also has to be 120 degrees as well. So notice, if I add up all of the angles on the outside of my triangle, on the exterior, notice what it adds up to be. 120 plus 120 plus 120 equals 360 degrees. Well, maybe that just works for a regular triangle, right? Well, let's try it with a square this time. So if I had a square, again, the characteristics of a square is that all the sides are going to be the same. Means all the angles inside are also going to be the same. And so every angle inside, let's use our blue color again, is going to be 90 degrees, right? So then if I start talking about the exterior angles here, again, this is a straight angle, makes 180 degrees. So that means this also has to be 90 degrees. What if I do that all the way around? And you're going to kind of get the idea now. If I do that all the way around, then that also means every one of these angles here have to also be 90 degrees. And what if I add all those up? 90 plus 90 plus 90 plus 90. Ladies and gentlemen, look here. It happened again. It still adds up to 360 degrees. So my point to you with this is any exterior polygon, any regular polygon, the exterior angles are going to add up to, or going to sum 360 degrees. I don't care how many sides it has, it's still going to add up to 360 degrees. And so what if we were given something like that pentagon again, a regular pentagon, and now all of a sudden I am asked to figure out what this individual angle is right here on the outside. What if I'm asked, okay, what's X? Well, again, because all of these are the same, notice every one of these were the same. 120 all the way around, 90 all the way around. So I've got to conclude that these are going to be the same as well, right? But what do I know? What I know right now is that this is going to add up to 360 degrees. If I take all these just like I did all the other ones, it is still going to add up to 360. So watch how easy this really is. I'm going to take 360 degrees and I'm simply going to divide how many sides I have, or n. So with a pentagon, I have 5 sides, correct? So here I'm going to take 360 divided by 5, which is going to give me, wait for it, 72 degrees. That means every single one of these exterior angles is going to be 72 degrees, okay? So there's your 3 rules, okay? Basically, your 3 things that you're going to be using is 360 divided by n to find exterior angles. If you are finding individual interior angles, you're going to use this right here. And if you are just finding the sum of interior angles, then you're going to use this formula right here, okay? So hopefully this has been helpful. If you need help, obviously reach out to us. Again, I have put some posters and some other things on here as well to try to help you. So hopefully those will be a help as well. Thanks.